So we know the opposite, or we know this vertical leg is 12 feet. We know this is 7 feet. We want to know angle A, and we want to know that hypotenuse F. All right, let's start with the easier one here. How can we find the value of the hypotenuse with the given information? Right, so we start with the Pythagorean theorem. Specifically when we're using a right triangle, C is always the hypotenuse. So what we don't know here is F. Right, it's going to be the square root of the sum of the squares of the legs. So just taking the square root of both sides. So 12 squared plus 7 squared. In this case, the value for F we get 13.9 feet, since again the other two legs were measured in feet. All right, so that one's easy enough. How can we find the value for A, the angle between the hypotenuse, the included angle between the hypotenuse and the 7 feet?
Tangent?
Right, one method is we could use tangent. So again, the definition of tangent, the tangent of that angle A is going to be the opposite over the adjacent. How else could we find the angle A? Right, we could use sine, we could use cosine, because by now, again, we know the hypotenuse. My same argument as before, the hypotenuse we rounded off, so I would say this is a better way to do it, but it's fine to use cosine of A would be 7 over F, or that the sine of A was 12 over 13.9. Again, to 3 digits, it's going to be the same thing. So to find this, we can take the arctangent, or the inverse tangent of both sides. So we take the arctangent of 12/7. We're going to get that angle to 3 digits, 59.7 degrees. Like I said before, for angle measurements, degrees is going to be our preferred method of reporting, but there will be times we do specifically have to use a measured in radians for something to work.